Hello, everyone. My name is Stephen McNeil. I'm here giving you a summary of my project for CSCI E-90 exploration into AWS DeepRacer. AWS DeepRacer uses reinforcement learning technology and a 3D racing simulator to basically train a self-driving capable car on the best way to go around this track in a virtual environment. So I'm going to walk you through some of the things that I did, but first, here is the finished product. This is actually the evaluation of the fourth model that I built. I built 4 models in total. This is the last one. And I just wanted to show you what the finished product looks like to kind of give you a better idea of where we're going. So here is the technology infrastructure for AWS DeepRacer. It is the overall encompassing technology you see here around the outside. Within that, we have a VPC, and within the VPC, we have Amazon SageMaker, which is like our sandbox environment where we have our data science tools and essentially create our reinforcement learning models. That communicates with AWS RoboMaker, which creates the virtual environment that the track that I just showed you. That goes into the NAT gateway, and then the NAT gateway distributes the models to the S3 bucket, the videos to the Kinesis stream, and then the metrics to Amazon CloudWatch. So that's our technology infrastructure. And so it has a lot of capabilities kind of built into it, but you can access, well, all of these are really built into DeepRacer. So you can do these manually. You can create this manually, create a stack, or you can create a model like this. So you create your model. You can take the course if you want to. I actually did. And then after that, I created my model. So here's me creating, I believe, my 4th model, the one that I just showed you the video of. And you give the model a name. After you name the model, you pick whatever track you want to train the model on. So once I'm done giving it a name, I'll scroll down and pick whatever track I want to. So I kept a lot of these parameters, the base parameters, the same, just to kind of keep those controlled. And then I played with the reward functions to try to see which one was the best. So I've got my same track every time, and then I've got the time trial, and then the PPO algorithm and hyperparameters. So the hyperparameters here are really relevant to the reinforcement learning. I didn't play with those. You may be familiar with those if you are familiar with the reinforcement learning. Here's some other ones in the action space. So the steering angle you can play with, and also the max and min speed of the car. You can select your shell, but there's only one choice. And then here's the reward function. This reward function rewards the car for staying close to the center line. And then we've got our stop condition, which is essentially how long the model is going to train. So it's going to train for 60 minutes. And here we go. I think we're ready to start rolling. This next part is going to go really quickly because, we have a short amount of time. But you can see the training reward in the green, and then the track completion in the red and the blue. You see it's increasing over time. And then I've got a quick snapshot of the car training over there on the right. Now we're going to actually evaluate our model on a new track that we did not train on. So this process is called generalization. When you build your model, you want to see how well your model generalizes to new information, which in this case will be a track that we have not trained on. So we had the 2018 re:Event track. Now we've got the 2022 re:Event track. And here's another process of the car going around this new track. It's going to make it all the way around, and I believe the time will be 42 seconds. There we go. And so here's actually a diagram of that model creation process. So we went through creating the model, training the model, configuring the model, training the model. I showed you the last step I just showed you was evaluation, and then I tweaked the model using different reward functions. So I used 4 in total, and you'll see that if you watch the full video on YouTube, you'll see that. Thank you.